The battle for AI is raging, but the front line just shifted. It's not just about who designs the fastest chips anymore, it's about who can actually build them.
For the longest time, the race for AI dominance was all about who could design the most powerful piece of silicon. Well, that era is coming to a close. The real fight has moved to a totally new battlefield.
It sounds kind of crazy, right? But this question gets right to the heart of what's happening. The key to unlocking more AI power isn't inside the silicon, it's in this space between it. It's all about the packaging.
Okay, so what is going on? Well, the entire AI industry is hitting a wall, a new bottleneck, and it's not in chip design or the fabs, but in the final, absolutely crucial step of putting it all together.
And that brings us to this key idea: advanced packaging. Seriously, the best way to think about it is like building with super high-tech Legos. Instead of making one giant monolithic chip, you take smaller, specialized chiplets, one for computing, one for memory, and you assemble them into one incredibly powerful processor.
For decades, we got performance gains from Moore's Law, just cramming more and more transistors onto a chip. But, as the sources point out, that's getting incredibly difficult and ridiculously expensive. Just shrinking things down isn't the easy win it used to be.
And this is the new reality. The biggest jumps in performance, they're now coming from how cleverly you can package these little chiplets together. The problem is, there's just not enough global capacity for this advanced packaging, and it's created a huge choke point for the entire AI industry.
This bottleneck is completely reshaping the competitive landscape. One source even calls it a warring states era, where you have all these huge powers fighting for control over this one critical piece of technology.
So, first up, you've got the king of the castle, TSMC. Their packaging platform, called CoWoS, is the absolute gold standard that every single top AI company is desperate to get their hands on.
What's really wild is how one company just dominates this space. According to the sources, NVIDIA has booked over half of TSMC's entire CoWoS capacity all the way through 2026. That leaves everyone else, we're talking AMD, Google, you name it, fighting for scrap.
The demand is just insane. To keep up, TSMC is scrambling to almost double its output. They're aiming for a monthly capacity of 130,000 of these special wafers by 2026.
And when you have that kind of scarcity, you get conflict. And that leads us to our next key point: a massive collision course between two of TSMC's absolute biggest customers. Okay, here's the conflict. On one side, you've got Apple. They used to use simpler packaging for iPhones, but now for their next-gen Mac chips, they need the absolute best stuff, CoWoS and another tech called SOIC for stacking chips vertically. But guess who's been hogging those exact production lines for years? NVIDIA, for their AI GPUs. So all of a sudden, they are direct competitors for the same very limited capacity. The takeaway here is pretty simple, right? When the main highway is totally jammed, you start looking for backroads. This massive bottleneck to TSMC is forcing the entire industry to find other options, and that's creating huge opportunities for other companies. The main alternative right now is coming from Intel with its EMIB technology. Let's break down the trade-offs. TSMC's CoWoS uses a big single piece of silicon to connect everything. It gives you the highest performance, but it's really expensive. Intel's EMIB is different. It uses these small, clever silicon bridges to connect the chiplets. It's more cost-effective and easier to scale up, which makes it really attractive for companies like Google and Meta building their own custom chips.
So the result of all this is what the sources are calling a DTSMC-centric supply system. It's no longer a one-company show. Intel's gaining ground, and these specialized OSATs, companies like Amkor and ASC, are becoming absolutely critical partners for everybody.
Now, this isn't just a technical squabble. This is a big deal geopolitically. The packaging wars are literally redrawing the map for the global semiconductor supply chain with a huge push to bring this advanced manufacturing back to the US.
And you don't have to take my word for it. Just listen to this quote from NVIDIA's CEO Jensen Huang. He calls Amkor's new Arizona facility a defining milestone in rebuilding the supply chain on American soil.
And this isn't some far-off plan either. It's happening fast. Construction on that Amkor campus is set to finish in mid-2027, with production starting just a few months later in early 2028.
And here's the end game, the really big picture: a $7 billion campus in Arizona that will package chips for both Apple and NVIDIA. So think about it. Wafers will be made at TSMC's nearby Arizona plant, then sent over to Amkor for packaging.
This creates the first complete end-to-end advanced chip supply chain in the US.
So where does the packaging war go from here? Well, the technology and the strategies are evolving at an incredible pace. Here's what the sources say to watch for. First, TSMC isn't standing still. They're advancing their own tech with things like CoWoS-L for bigger designs and SOIC for that vertical 3D stacking. Second, and this is a big one, Apple is apparently evaluating Intel's EMIB for its own Ultra AI server chip, all because of the capacity crunch at TSMC. And finally, the whole industry is researching the next big breakthrough, panel-level packaging.
Okay, I know that was a lot to cover. Let's boil it all down to the key takeaways. Okay, 3 things to remember. 1. The fight for AI dominance is no longer just about making tiny transistors. It's about advanced packaging. 2. This has made Apple and NVIDIA direct rivals for the exact same limited manufacturing capacity. And 3. That bottleneck is creating a brand new, diversified supply chain, with companies like Intel and Amkor playing a more critical role than ever, especially in the United States.
This leaves us with a fascinating question. The era of a single dominant supply chain is over. As these new ecosystems compete, the race is on to see who will build the physical foundation for the next decade of AI.